My name is Justin Mahaffey. I'm a sales engineer with Littelfuse, and today we're going to talk about the PGR 8800 arc flash relay. An arc flash relay is a relay that uses sensors to visually see an arc and send a trip signal to a shunt trip breaker upstream. An arc flash relay can lower PPE requirements by seeing the flash and sending the trip signal in less than 1 millisecond. This is our PGR 8800 arc flash demo case, and what you're seeing here, this is the relay itself. These are connections for the sensors. These are our CTs. These sensors are connected to each one of these sensors, both optical and point sensors. These are our two breakers that are representative of our main breaker, and then a secondary breaker that's actually upstream of the main. We can trip both of these systems with some of the optional settings in the relay. The PGR 8800 utilizes two types of sensors to detect arc faults. One is our point sensors that you see here, and the other is a fiber optic sensor, which is actually an 8-meter fiber optic rope. So it's equivalent to around 25 feet. The fiber optic cable can conduct light from end to end. In this example, you only see about 8 inches of the exposed fiber, when in fact you can see an arc flash end to end for the entire 25 feet. The red flashing light was developed so that we would know the sensor was in the circuit. However, it did have a secondary advantage, being that if a worker opens a cabinet, in a dark cabinet they can see this red pulsing light and know that the sensor is still in full operation. If they were to open a cabinet and they saw no light at all, or the sensor wasn't flashing, they would know to close the cabinet immediately because they weren't protected by that sensor. The fiber optic sensor also has the same double pulse that you see in our point sensors, but what's happening here is that we have a transmitter and a receiver. So when the double pulse flashes, it goes through the fiber optic cable and it's received on the other end. By turning this switch off, we actually cut the connection with the receiver of the fiber optic cable, and you can see that we have a sensor fault on sensor 4. Same with the point sensors. Here I am disconnecting the point sensor. The unit was sending the signal, it's not getting the red pulse back, so we have a fault on sensor 2. There is a local sensor on the front side of the relay itself, because if the sensor is mounted in the control cabinet and you were to have a small flash inside the control cabinet, it would also pick that up. When an arc flash occurs and the light is seen, and I'll demonstrate that with this camera flash, the sensors change status. As you can see here, every sensor saw the flash, but if this were a divided cabinet and everything is dark, but you're running the relay off of a battery backup control power, you would still see which sensor had the fault, so you would know which cabinet that the fault was located in, even in the dark. These two breakers represent breakers that would be upstream of an arc fault. Breaker 1 is going to be the breaker that's directly above the fault. Breaker 2 is going to be the distribution breaker that's actually above the breaker that was feeding our subset. This breaker reacted, this one did not. It's because we're tied into this one. We do have another feature in our relay where if this breaker were to jam, we could then trip this breaker off that actually feeds that main breaker. If I were to set this in fail mode, it would then bypass breaker 1 because it represented a jam breaker scenario. It would then pass the main breaker and go up to the secondary breaker that was feeding the main. The CTs that you see in the diagram are representative of CTs that can be added to our relay. We would add the CTs in there if someone had concerns of maybe high ambient light or someone opening a door panel. If the unit sees a flash, it will then ask the CTs if they see an overcurrent. If they see a flash but no overcurrent, the unit won't trip. Line voltage. If you were to bring it in with control powered AC, you would have a light here. Power. We're powering the unit with DC. Our link says that we have 2 units linked together to tie into one shunt trip breaker. Our reset is for the remote reset. Online lets you know that your relay is online. We have 2 types of service modes. One is for an initial setup. The second will engage the trip coil. Trip, this can be used to send to a system to let you know that you had a trip, or it can be tied to a secondary breaker This is our trip coil. It's an IGBT that's tied to the shunt trip of the breaker. The IGBT transistor acts as a fast-acting switch to engage the shunt more rapidly than if we were to use a dry contact. Our mode button to toggle the unit into service mode for an initial setup. The trip button you could also use to test the unit. And we have the reset to reset after a fault. There is a local sensor on the front side of the relay itself, because if the sensor is mounted in the control cabinet and you were to have a small flash inside the control cabinet, it would also pick that up. When you connect into the USB port, the software and device drivers automatically load into your computer much like a jump drive would. So you can do your initial setup from there, but you can also view the currents for each phase at the time of a fault. You can also see the intensity of the light at the time of the fault via our event logger. We were privy to some testing in Mexico where we submitted our sensors to over 10 arc flashes and never changed a sensor. They were jet black but still conducting light even through every flash.